video, we taught you the constant rule for deriving an equation, and here's another rule to help make deriving equations a bit easier, and it's called the power rule. So if you have an equation that reads x to the nth degree, if you derive that, it'll become n, so your exponent, times x to the n minus 1th degree. So let me just show you an example here. So we have this equation, f of x equals x squared plus 1, and we want to derive that. So we would write f prime x, that's another way to show that you're deriving it, equals n times x, so this is our n, we multiply that times x, so we have 2x, and we want to put x to the degree of n minus 1, so if this is our n, we subtract 1 from it, and that would put x to the first power, because 2 minus 1 is 1. But we don't really have to show that, because x to the first is just x. And remember the constant rule that we showed you in the last video? This, since it's a constant, would become 0, so plus 0. But again, you don't have to show that. So whenever we derive it, we get f of x equals 2x. And I just wanted to show you that you can combine the rules. You don't just use one rule the whole time. So yeah, we have our derivative, 2x, and let's graph it to make sure we're right. So we have 0, 0, 0, 1, 2, 1, 2, negative 1, negative 2, and negative 2, negative 4, and then 2, positive 4. That's 5. Alright, so if we graph that, sorry, that's an ugly line, but we can check to see if it matches up. So right here we have a negative slope, and our derivative is in the negative quadrant. And then right here, the derivative is 0, so your graph should cross the x-axis here. And then we have a positive slope, and our derivative is in the positive quadrant. So we can assume that this is the right derivative.